All right, let's get right into it. You've got a 2001 Grand Marquis, it's a no start, and you're pulling your hair out. You know you've got power in the trunk, but when you get underneath, nothing. It's gone. And look, we all know dropping that tank is just not going to happen, especially when it's freezing out. So let's figure this out the right way.
Okay, so let's just make sure we're talking about the same exact problem here. It's a 2001 Grand Marquis, and it just won't fire up. You've already done the legwork, right? You've confirmed you've got juice at the inertia switch and the FPDM back in the trunk. But crawl underneath to the fuel pump connector and zip. 0 volts. And of course, the biggest headache of all, you cannot drop that tank because those studs will snap right off. If that sounds familiar, then yeah, you're exactly where you need to be.
So this really boils down to one big question, doesn't it? What happened to our voltage? Are we looking at a simple broken wire somewhere in that harness that runs along the frame rail? You know, a physical break? Or is something smarter going on? Is the module itself actually deciding to cut the power? Answering that one question is how we're going to crack this thing without touching those tank straps.
And here they are, our two main suspects. You've got suspect number 1, a straightforward harness failure. This is just a physical break, an open circuit. Simple, right? But then you've got suspect number 2, and this one's a little more clever, the FPDM logic shutdown. This is where the computer, the smart module, is making an active choice to kill the power. Two totally different problems, and there's one test that's going to tell us which one we're dealing with.
But hold on, before we even grab the multimeter, we got to wrap our heads around what we're actually working on here. This is not your grandpa's fuel system. There's no simple relay that just clicks on and blasts 12 volts to the pump. Nope, this thing is, well, it's smart. And if you don't understand how it thinks, you're just going to be chasing your tail.
What we're looking at is what Ford calls an electronic returnless fuel system. Basically, forget on and off. Think of it more like a dimmer switch for your fuel pump. The main engine computer, the PCM, doesn't talk to the pump directly. It sends a message to a middle manager. That's our fuel pump driver module, the FPDM. And it tells it, hey, I need this much pressure, and the FPDM spins the pump at just the right speed to make it happen. It's all about precision control. And yeah, the service manual backs this up perfectly. It says the PCM commands the FPDM, and the FPDM uses that information to change the output. See the language there? This module isn't just a switch, it's a processor. It's an active participant. And here's the absolute key to this whole diagnosis. If a module has the brains to vary power, you better believe it has the brains to cut power completely if it thinks something's wrong. All right, enough theory. Let's get our hands dirty. Now we're going to see how all that smart module talk actually helps us fix this car. We can do one simple test right from the trunk that's going to give us a definite yes or no answer. Is it the wire or is it the module's logic? Let's find out.
First things first though, safety. Do not skip this. The manual's dead serious about it. Disconnect that negative battery cable and don't just tap it off, let it sit for at least a full minute. You've got to give those modules time to fully power down and drain their capacitors before you go sticking probes in places.
Okay, here's the game plan. It's a dead simple continuity test. You're going to unplug the FPDM connector there in the trunk, then you're going to crawl underneath and unplug the connector at the fuel pump. Grab your multimeter, switch it over to ohms, and we're just going to check the wiring path. We'll probe the power wire between those two plugs, and then we'll do the exact same thing for the ground.
So yeah, this is just a classic continuity check, plain and simple. We're asking the multimeter one question. Is there a complete, unbroken copper road from the trunk to the tank? If the wire's good, we should see almost zero resistance. If that wire's broken somewhere along the way, we've got an open circuit, and that meter's going to scream infinite resistance at us.
And this is it. The answer to our big question is about to show up right on the screen of your meter. This is the moment of truth. So let's talk about what those numbers actually mean.
It really doesn't get any more black and white than this. If you put your probes on either that power wire or the ground wire, and your meter reads OL, open line, infinite resistance, boom, diagnosis done. You have a broken wire. That's a harness failure. But if both of those wires read super low, less than 5 ohms, then your wiring is perfectly fine.
So that leads to the big what if, right? What if your wires check out perfectly? You've got good continuity, but you know for a fact there were 0 volts at that pump connector. So, where did the voltage go? Well, now we know we're not chasing a broken wire. Now we're looking squarely at suspect number 2.
And this is all about the FPDM's self-preservation logic. It's programmed to be smart. When you turn the key, it sends a little test signal down the line. It's basically asking, hey, is the fuel pump motor there? It's looking to feel the electrical load of that motor. But if your connector is junk, it's corroded, full of crud, or maybe it's just not clicked in all the way, the FPDM sees nothing. It sees an open circuit. To the module, that means no load, and it immediately says, whoa, something's wrong, and it shuts down the power of that circuit to protect itself. No load, no power.
So there you have it. That one simple test gave you your answer. You know for sure now if you need to fix a wire or if you just need to fix a bad connection. So let's walk through the repair for both of those scenarios.
Okay, so your meter showed an open circuit. You've got a harness failure. Look, the best way to handle this is to just run a new wire. Don't even bother trying to find the break or pull the old wire out from over the tank. It's not worth the nightmare. Just run a new, proper gauge wire right alongside the old harness, zip tie it securely, and you're good. And please, do it right. Solder the connections and use heat shrink tubing. Make a real, permanent, weatherproof repair so this car never comes back for the same problem.
Now, what if your harness tested good? Well, that means your problem is almost guaranteed to be right there at the fuel pump connector itself. Get in there and clean it out really, really well. Look for that nasty green corrosion and make sure none of the pins have gotten pushed back into the connector body. Then, and this is important, use just a tiny dab of dielectric grease. If you glob it on there, you can actually stop the connector from seating all the way. Then, plug it back in and listen. You have to hear and feel that solid click that tells you it's locked in place.
And look, no matter which repair you just did, you're not done yet. The last step of any good job is to verify the repair. So hook that battery back up, turn the key to on a couple of times to let that pump prime the system, and then make sure she starts and runs like she's supposed to. Just like the book says, you got to confirm you fixed the problem without creating a new one.
So I'll leave you with this to chew on for the next time you're faced with a tough electrical problem. With cars getting smarter and smarter every year, you have to ask yourself, when I see 0 volts, should my first thought be broken wire or should it be logical shutdown? Knowing when to suspect the computer's decision-making, well, that's what makes all the difference, isn't it?